Alright, let's look at the practice exam 3, problem number 6. Alright, so we want to find the absolute minimum value of this given function here. Alright, so let's do that. Alright, so we need to take the derivative so that we can find the critical number. Alright, so let's do that. But the first thing is I'm going to actually rewrite this guy as 9 times x to the negative 1 power. Right? Right, let's find the derivative. So f prime of x is equal to, right, so derivative of 4 is 0, derivative of x is 1, right? Derivative of 9x to the negative 1 power would be put negative 1 in front, so it's going to be negative 9. Then x to the subtract 1 from the power, so it's a negative 2 power, right? So I'm gonna rewrite it this way, so I can probably write it as 1 minus 9 over x squared, and taking the common denominator, I can have x squared minus 9 over x squared. Alright, so I'm gonna just factor out the top, so you have x plus 3 and x minus 3 and all over x squared, right? So I'm gonna set this guy equal to 0, and we get x equals plus or minus 3, right? So these are critical numbers, right? But we're trying to find the minimum value over interval from 0 to infinity. So only critical number on that interval is actually 3, right? So if you have only one critical number, then if this is a local minimum, then it's guaranteed to be absolute maximum, right? So let's make sure that this is going to give us a local minimum, right? So one way to do is we can probably look at the second derivative. We can do also a first derivative test. But for this one, I'm going to do a second derivative test, because second derivative is fairly easy to find. So f double prime of x is equal to, alright, so derivative of this guy, so derivative of 1 is 0, right? Derivative of negative 9 to x to the negative 2 would be, put negative 2 in front, so negative 9 times negative 2 is positive 18, right? X, and then subtract 1 from negative 2, so negative 3 power, right? So which is going to be just 18 over x cubed, right? So we plug in the critical number, in this case positive 3, into that, so you're going to get this, f double prime of 3 is equal to, right, but 18 over 3 cubed, right? So this is actually, we just need to know if it's positive or negative, but there's nothing negative about it. So this guy is positive, right? Which means that by second derivative test, f of 3, so f of 3, which is, we just need to compute that, it's a 4 plus 3 plus 9 over 3 is going to be, let's see, so that's 7 and that's 3, so it's 10, right? So this second derivative test tells you that this is going to be a local minimum, right? Because the second derivative tells you about concavity, and if the second derivative is positive, so we're basically looking at this concave up shape, then the critical number shows up right here, right? So it's at the bottom of the valley, so we know that this is a local minimum. But we can say a little bit more than that, because this is the only critical number on this interval. This is actually a global, or I should say absolute minimum. So therefore, f of 3 which is 10, is the absolute minimum value. Right? Alright, that's it. I hope that this was clear.